Thank you. How's everybody doing? Good. This has been some fantastic presentations today. It's been really interesting on my end, and just love seeing all the different tools, models, insights, even great missing context and information that we need to make sure that we capture in the city. So it's been really helpful and informative for me. What I hope to really focus on in my talk today is in a city like Chicago, we have to decide what we're going to do when we learn the information that comes from a model or a product. And that gets tough because if information that we're learning requires doing something new, that takes resources and costs money. So oftentimes products and models will help us do something cheaper, or will help us have more of an impact expending the same resources that we already expend. And those kinds of activities might actually free up resources to take on some of those great insights that we need to expend a few more resources to do something about. So I'll get into it here. Let's just start with open data. I have to cover this still because I can't underemphasize the importance of open data in unlocking what's possible from a machine learning or analytics standpoint in a city. It's the goal is to put as much data on the open data portal as we can without compromising privacy. Really, open data started as a transparency thing in cities, and it's moved to become a catalyst for all sorts of other things beyond just transparency. And people just wanted to know, what's going on in the city? What do I not know about a city? And that's where it all started, but it's become so much bigger than that. Chicago has over 600 data sets on the data portal right now, everything from crime to the water quality at beaches to Uber trips, Lyft trips. We have taxi rides, all kinds of data. And that's sprung a community around the data portal. So there's nonprofits, there's civic tech hack nights. People get together and try to use the data to make the city a better place. We also open source our code and the data that we put out there. So one great back and forth collaboration is that we have building footprints that we'll put on the portal, and then OpenStreetMap will take those and put them on their tools so that there's that two-way street. So we collaborate with a lot of academic institutions. We have the University of Chicago, we have Northwestern, we have a lot of other universities in the area. We can't do this kind of work alone. We don't have enough team. We'll never have a big enough team to be able to do what's possible. So open data plus partnerships really expands what's possible in a city. So I'm going to talk a little bit about our sensors. We have some sensors up on telephone poles. Now we have, I think, over 100 of them. We're able to get pollution data, air quality, vibration, noise, all sorts of great information that we've never had at this micro of a level. And that data is being made open for researchers to be able to unlock insights from. So I'm going to get into machine learning now. We'll start off with a little video. And we're going to talk about the beloved rat. Has anybody been in Chicago and seen a Chicago rat ever? All right, great, we have some. So the goal here, I guess my video moved, but there's no way that we're ever going to be able to fully eradicate rats with a handful of inspectors that we have available. There's no way we're going to be able to go out and bait all these rats. So we have to choose where we're going to expend resources. And this was one of the city's first machine learning models where colonies were predicted where they were going to form and get really large. And so the areas were baited in a way that would prevent those colonies from exponentially growing. And so this is an example of a problem where if you take the resources that are available and you put them in a place where you get the biggest impact, then you really unlock the power of what machine learning and analytics can do for a city. And I'm just going to go through a series of projects where we see that pattern over and over again, where we've got a problem, we have a resource problem, and expending it in a certain way unlocks huge benefits. A little bit about the model for the rodent prediction. We, of course, choose models that are interpretable, transparent, and simple. So these models aren't complex. They're pretty intuitive when you look at what the predictors are, but they're models that a person sitting with pen and paper or looking at databases is just not going to be able to replicate on their own. We also, when we build a model, it's very important to operationalize it and give the people who need to do their job a clear way to see the results so that they can organize their work. Models aren't by themselves going to determine what happens. People make decisions based on data. And so we give our employees tools so that they can look at scores and then they can make their decisions about how they want to go out and divvy up their work. But of course, we measure traditional methods versus data-driven methods to make sure that we know what's the better method. Now, back to the partnerships, we can't do it all ourselves. So we've partnered with, on one project, an insurance company in Chicago that has data scientists that are just always looking for public good work. They want to donate their time. And so we've tried to create a platform to be able to take advantage of that work and really expand our reach. And unfortunately, this example is going to be a little close to home for some people. Last night, I guess, I heard about. But it's restaurants. So there's thousands of restaurants in the city, and there's only 50 or so inspectors. There's no way that those inspectors can get out to all the city restaurants, even on an annual basis. So we use machine learning to take the population of restaurants that they might inspect and whittle it down to the restaurants that have the highest likelihood of having a major problem that causes food safety issues. So it's another reorganization, limited resources. Where are you going to send them so that you can do the best good for people? And again, predictors that make sense, temperature, 3-day average high temperatures, garbage complaints, things like the length of time since the last inspection, past critical violations. And looking at a rigorous evaluation, we've seen that the model-driven method had a higher likelihood of finding problems with restaurants and overall helped the city get to these issues 7 days faster. That's 7 days of people getting sick eating food, 7 days of lost work time, 7 days of medical expenses. So the idea here is to continue to find those niche areas where you can reallocate resources like this. Again, we deliver this to the team with a tool. And we put our code on GitHub. We put our data on the open data portal. Try to be as transparent with everything as possible. We ask researchers to evaluate our methods. We ask other cities to adopt our methods and see if they get the same results. And then we hope to get the contributions back so that we can enhance our methods. All right, I'm going to go to another one. Has anybody been to a Chicago beach? All right, we have some hands. You've experienced machine learning in Chicago. So this one, there's only a couple ways to test a beach water for quality. Most of the days in the year, the water's fine. But a few days each year, there's E. coli buildup, naturally occurring E. coli buildup. And you either have to go cheap, and it takes almost 24 hours for the test to come back, or you can go expensive, and you can get 3 hours almost immediate results. But that's very expensive. So there's a need here to have a model that can issue predictions to let people know whether the water is going to be potentially have some contamination and maybe make people sick when they get in it. Then you can put a flag up, you can send a notice out, and you can say, hey, you might not want to go swimming today. So this is another model we built, used water sensors, weather sensors, some testing, and also water levels just to predict the likelihood of contamination. I'm going to skip some of these slides to go fast. Want to name another project where we have a blood lead level predictor for clinicians in doctor's offices. The main idea here is in buildings built before 1978, there's lead paint in them almost always. But only in buildings that are deteriorated are those going to be an issue for kids. And so there's a model that looks at building age and some other characteristics to determine whether it's likely that a kid that's grown up in that building might have an elevated blood lead level. So this gives practitioners a way to see a patient, and normally they would just be making a gut call. They would maybe look at the neighborhood and think like, oh yeah, I know there's a lot of old houses there. And then they would determine, their testing schedule based on something like that, or asking questions. Now they use this and they get great information on the buildings and the conditions and the age, and a score that helps aid them in their determination of when to do testing. How am I doing on time? Yeah, wrap up. Mosquitoes, West Nile virus. We have a model that determines whether West Nile virus is going to be in a certain area, send the mosquito trucks out, spray that area. The idea is you don't want to spray the whole city. Nobody wants mosquito spray throughout the whole city, so target it. It's cheaper and it's safer. So another application of machine learning. And I just want to talk a little bit for just a few seconds about the future. We're collecting so much data. It's crazy. We have so much data coming in from transportation methods. We've gone from 0 miles traveled each year in Uber and Lyft vehicles to over 600 million miles traveled each year, and it's growing. And so a lot of the talks today, I think we're really focused on this, but this is, I've named a lot of different things we've been doing with machine learning. Now we have to figure out what are those key things we can do something about in this area. And that's what we'll be doing in the future. So with that, I think I'll wrap it up. And I think, is it time for questions?
Yeah, that was time for questions.